Hello Year 10. This video goes through the model solutions for the diagnostic homework sheet, which is your revision for the topic test. Use the video to mark your work. There is a full set of answers at the end if you wish to check them first, and then watch the parts of the video that you might need to help you with any corrections. So, question 1. We have got 5 students, and we need 2 from these 5 students to represent Year 11. Now we could answer part A using the product rule for counting idea, but I've drawn a sample space diagram here because I think it will help me with parts B, C and D. So we can see here students A, B, C, D, E and the second student A, B, C, D, E. Obviously a student can't be paired with themselves because we need 2 students, so that's why there's a line of crosses there. And because we're choosing 2 students, if we choose student A and B, then student B and A is the same pair of students. So I'm going to discard all those. So I can now see that there are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 combinations. So how many combinations of 2 students are there? There are 10. What is the probability that Amy will represent Year 11? So out of these 10 combinations, 4 of them contain Amy. So the probability that Amy will be included is going to be equal to 4 out of 10, or any equivalent fraction. So 2/5 or 0.4 if you want the decimal. What is the probability that Ellie will represent Year 11? We'll look through here. I've got 1, 2, 3, 4 pairs, 4 combinations that contain Ellie. So the probability of one of my combinations including Ellie is also 4/10 or 2/5. And then the last one, what is the probability that Callum and Dan will represent Year 11? Well, there is only one combination containing Callum and Dan. So the probability that Callum and Dan are chosen to represent Year 11 is just that 1 out of 10. Question 2 actually asks you to fill a sample space diagram in. So we have a fair dice and a fair spinner, and our results are the total of the 2. So filling that in, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, and 5, 6, 7, 8, 9, 10, where each box is the total of the dice score and the spinner score. So work out the probability of getting a total of 4. Well, there are 1, 2, 3, 4, 5, 6, 24 possible totals altogether in that sample space diagram. Total 4, there are 3 of them. So the probability of getting a 4 is 3 out of 24, which is 1/8. A total that is a square number, well, those 3 are square numbers, as are those 2. So the probability of getting a square number is 5 out of 24. And the probability of getting a 12, well, there are no 12s. Cannot get a total bigger than 10, so the answer is 0. Don't bother with 0 out of 24, it's just 0. So, mutually exclusive events, so things that can't happen at the same time. Again, a fair 6-sided dice is rolled once. We want the probability of rolling a square number or a multiple of 5. I'm going to do these answers up here. I need a bit of space, I think. So the probability of, so which is this, question 3, isn't it? Question 3. Probability of a square number or a multiple of 5 is going to be, well, 2 out of the 6 are square numbers. That's 1 and 4, and there's only one multiple of 5, so that's 1 out of 6. The answer is 3 out of 6, so 3/6 or 1/2. Probability of a prime or a multiple of 4. Well, there are 3 prime numbers. That's 2, 3 and 5, and there is one multiple of 4, so plus 1/6, and the answer is 4/6 or 2/3. And then my last one, just have enough room to fit it on, probability of a square number or a multiple of 3. And that's going to be, again, there are 2 square numbers, so 2/6, and there are 2 multiples of 3, 2/6, so that's 4/6 or 2/3. Okay, question 4, one of the tree diagrams. So Joe plays a spin the wheel game 3 times. The probability that he wins is 3/5, and he either wins or he loses. I don't think you can draw these. Draw a tree diagram to represent it. So this is his first go, his second go, and his third go. I'm going to choose that is my direction for winning, and that is the direction that he loses. Now if he wins, probability of him winning is 3/5, which means if he doesn't win, he loses, that's 2/5. Each one of these is 3/5 and 2/5, because each go is independent of the previous one. So there's my tree diagram. It says calculate the probability that he wins 2 out of the 3 games that he plays. It doesn't say the first 2, it means any 2 out of 3. So what I'm going to do is I'm going to write down at the end of the tree, at the end of the branches, the outcomes for that branch. So this will be win, win, win. This will be win, win, lose. This will be win, lose, win, and so on. Lose, win, win, lose, win, lose. Lose, lose, win, lose, lose, lose. And you can see, if I want to identify that he wins 2 out of the 3 games, that's this branch, and this branch. So I know that if I wanted to work out the probability for the end of this branch, it is 3/5 times 3/5 times 2/5. Each of these branch endings is a combination of a 3/5 multiplied by a 3/5 multiplied by a 2/5. So if there's 3 branch endings that are all the same, I want then the probability of 2 wins out of 3 is going to be 3/5 times by 3/5 times by 2/5, and there's 3 of those. So that's 3 lots of 18 over 125. Can't quite fit it on the bottom of the page, which is 54 over 125. Okay, moving on to the next part. Venn diagrams. So we have here, Lucy has carried out a survey of 150 students to find out how many students play an instrument and how many play in a sports team. And we have some information here. The first thing we need to do is to draw a Venn diagram. So I've got my universal set, and I know that I've got one of these represents students who play instruments, and the other one is students who play in a sports team. So we go 63 students play on a school sports team, so all of that circle there is going to contain 63 students. 27 play an instrument and play on the sports team, so that's the intersection here will have 27 people in it. We know the whole of the sports team circle is going to be 63, so that must be the difference between 63 and 27, so we have 36 in there. So altogether in that circle there are 63. We know that 72 don't play either an instrument or are in the sport or in a school team, so there are 72 people not inside the Venn diagram, which means we can work out this part because all of these must add up to 150. So 150 subtract 27 subtract 36 subtract 72 is 15. So there must be 15 people in there. And there is my completed Venn diagram. So work out the probability that a student plays an instrument. So students that play an instrument, that's the ones in this circle, that's 15 and 27. In total that is 42. So the probability that they play an instrument is going to be 42 out of 150, which cancels down to 7 over 25. On the second part, or the third part there, work out the probability that a student plays an instrument given that they play on a school sports team. The important thing there, given that. So we're only interested in the school sports team. There are 63 people there. And the people in that 63 who play an instrument, there's 27 of them. So the probability that they play an instrument given that they're in the school sports team is going to be 27 out of 63, which is equal to 3/7. Question 6. Into the problem solving ones now. So this table gives a probability of getting 1, 2, 3 and 4 on a biased four-sided spinner, so they're not equally likely outcomes. We can see that the ratio of these probabilities is 4 to 3 to 2 to 1. That's 10 parts in total. So this is 4/10, that's 3/10, that's 2/10 and 1/10, or 0.4, 0.3, 0.2 and 0.1. You can work in either fractions or decimals, it doesn't matter. So the probability of getting a 2 or a 4 is going to be equal to 0.3 plus 0.1, and that's 0.4. The probability of getting a 1 or 2 or 3 is going to be 0.4 plus 0.3 plus 0.2, which is 0.9. You can of course do 1 take away 0.1 to get the same answer. And the last question, question 7. Conditional probability. Callum either walks to school or travels by car. The probability that he walks to school is 0.65. If he walks, then the probability that he'll be late is 0.3. If he goes by car, then the probability that he'll be late is 0.05. And you need to work out the probability that he won't be late. The best way, I think, to do this is with a tree diagram to show you the various options. So the first section is going to deal with the travel arrangements. So he's going to either walk or he's going to go by car. He only does one of the two things. So if he walks, we know the probability of him walking to school is 0.65, which means the probability of him travelling by car is 0.35. Now if he walks, then the probability that he's late. So these next branches are going to deal with whether he's late or not late. So late, not late, late, not late. So if he walks, the probability that he will be late is 0.3 and not late is 0.7, because he can only either be late or not late. If he travels to school by car, the probability that he's going to be late is 0.05. The probability that he's not going to be late, therefore, is 0.95. Now, work out the probability that he won't be late. So, walking and late, walking, not late. So I want this branch ending. Car and late, car and not late. So I want this branch ending. So I've got two branch endings there. So the probability that is going to be late, not late, sorry, will be equal to either this branch ending, which is 0.65 times by 0.7, or this one. So add 0.35 times by 0.95. So that's 0.455 plus 0.3325, and my final answer 0.7875. It's the probability of him not being late. If you can see them, these are the complete answers. So if you want to check your own, check those first and then go back and look at any of the video for any of the solutions that you might need to see. Okay, and don't forget, this is revision for a topic test which is coming up.